Okay, so here we are one more time. We just did the geometry definition, and now we're gonna go for the hydrodynamic parameters that we're getting thanks to the frequency domain analysis, right? In this case, we're gonna use Ansys, Aqwa, as it's something valid for the Politecnico de Torino solution and also for the WEC sim solution, okay? So first thing we want to do is to go for hydrodynamic diffraction. We just do a double click here, and right click on geometry, and we're gonna go for new design modeler geometry. Here what we want to do right now is to import the IGS part that we exported from SolidWorks. Okay. So just file, import external geometry file, and we go for the IGS that we generated. We open it and we press generate. Okay, first thing we're gonna go is go for the XY plane, which would be the C in our case. And as you can see, we need to make a translation to put the body down. We want 50% out of the water, 50% inside the water. So we're going to go for create body transformation and a translation. The bodies, it's going to be this body, and we're going to do it by coordinates, right? Minus 0.1. So yeah, we're going to see it right here that it gets to the middle. After that, we're going to do a thin surface for the full body, outward 0, and the geometry is obviously this one. Okay, apply, generate. After that, we go for the slice. We're going to divide the body into parts, and the plane is this one. Okay, our body is generated. We have two parts right now. One will be the upper body, and the submerged body. We select both of them and form a new part. This part can be point absorber. That would be it. We generate, yeah, and we can go for the model. We finish with the geometry preparation. Close that, double click on model, and meanwhile, let me show you something. Now we're going to need the mass. That I know the mass depending on the draft, and I also need the inertia of the cylinder. No. To calculate the inertia of the cylinder, it's really easy, but I did it with an online solver. In my case, this one, I just put the radius and the length, and I got the inertia that now I'm gonna paste into the Ansys, right? That would be this number right here, 0.188 and 0.161. So now that we open the design modeler, we're gonna go for the depth, which is in our case 0.7 meters for our study. After that, we're going to create a point mass. Is this green ball right here, but we're going to change that. Okay, 3,201. In our case, we don't need to put it up or down because it's centered in the middle, and our point absorber is 50% draft, so it's okay like that, right? What we want to do is to change that for the size of the green point that now has exactly the same size than the cylinder. Okay, let's go on. What I just told you before, right? This is the inertia. We're going to put a direct input of inertia, and I got them right here, which would be, let me put a comma right here. Okay. This is the X and also the Y. And finally the Z, that is this one here. Okay, we're done with input of the negative. For the mesh, we can do basically whatever we want, as long as we can see enough definition. It's not a complex geometry, so it will be really easy to calculate everything. We're just gonna go for generate mesh, and let's see if it has at least a bit of sense, right? Okay, it has made sense, in fact. After that, we go to analysis settings, and there are three things we have to change here. First of all, the calculate full QTF matrix must be a no, so double click. This must be a yes, the ASCII Hydrodynamic database must be a yes, and we can ignore the modeling group relations, so it must be a yes. So let me check. Output ASCII Hydrodynamic database, it's a yes, right? Calculate full QTF matrix, it's no, okay. Ignore modeling group relation, it's a yes. Okay, this is only needed for the WEC to generate the AH1 file. Then let's go for the wave definition, for the wave directions. When we talk about wave directions and wave frequencies, in the WEC solution we can put whatever we want, okay? But when we do the Polytechnic Torino solution, we can only put one type of data. That is the one that we're going to use right here. So we put only one direction, and we're going to change all the frequencies. We put the 47 intermediate values, longest period 25, shortest period 2. But remember that in the case of the WEC, we can put whatever we want. In the case of the Polytechnic Torino, it is mandatory to put these values, okay? So now we go for the solution, and we just press, well, first let me save the project. I'm gonna go here, 20. Okay. Okay, we saved, and let's solve for the hydrodynamics. Okay, so to end with, it's always good to see the completed successfully that we can see right here, and also that the solution has a tick. So last thing we're gonna do is just go and check that the files we wanted are generated, right? So we go here, and we go to the file I created. It's always on the first file. Here analysis, there are two important files, okay? The list file is used for the Polytechnic Torino solution. Instead, for the WEC solution, it uses the list file and also the AH1 file. That's why we have to activate some parameters on the analysis settings, right? So we just take these two files, we copy them, and we can now go to the MATLAB and to the next steps.